The terms validity, reliability, accuracy, and precision are going to be needed in different places. Sometimes it's going to be needed in your methodology to explain why you've decided to do something different, because it'll increase reliability, validity, accuracy, or precision. Sometimes it will be to explain whether the data indicators with your calculations have improved or show strong or weak aspects of either validity, reliability, accuracy, and precision. Sometimes it's all four of them too, so you have to really think about it. And then, of course, your improvements will be improving one of those four things. Now, these four terms are expected in the IB. They're in your syllabus. I think it's under the tools section. It's more of a hang-up in the Australian system where it causes me a nightmare because they actually put the terms in the marking criteria, and because most students do biology, they ended up having reliability and validity. Whereas I think in the past the chemistry ones specifically had accuracy and precision and nothing else. And I'll talk about why that's the case. It's mainly because chemistry and physics are called the hard, inverted commas, science because they are about absolute truth and finding things and controlling everything, whereas biology can't really control any of their variables, so they have to use statistics, and they have huge issues with trying to make things valid or reliable. It's actually really difficult to do an experiment in chemistry that's completely unreliable, that can't be repeated, and completely invalid. But we'll try. I think over the years there's one or two weird things that have come up, which I'll add in later. So just make sure you have a good understanding of the definitions, and don't just say this improves, throw a dice and say precision and reliability. Yeah, that'll drive teachers crazy. Just say the one. If you want to say more, then use a separate sentence and say it improves the accuracy, and then explain how this thing improves the accuracy, so everyone knows what you're talking about and believes what you have to say. All right, no one's fooled by the random throw two magic words in there, okay? So first of all, accuracy is just the truth, how close it is to the truth. Now, I don't for any minute believe that this 100-gram mass is actually 100 grams, but let's just say it is. That would make the balance on the right more accurate, okay, because it's closer to the true value. Next one here is precision, which means how much it goes up and down. So if you get a much more expensive balance, like this will probably be a couple of hundred and this will be a couple of thousand, just to get those extra decimal points in. So this one goes up and down by far less. It'll go up and down by 0.0001, whereas this one has a much greater plus or minus there. It's far less precise. Okay? So have those terms fully understood and don't use them incorrectly. All right. So just a diagrammatic representation. This is what you normally see. Random error and systematic error are linked to it. So random error is linked to precision and systematic error is linked to accuracy. Go into that in a lot more detail in one of the last videos in this unit, which is on IAs. But this one here is very precise. It doesn't jump up and down a lot, but it's inaccurate. Whereas the average here is actually spot on, but they just jump up and down a lot, which is probably more like your experiments. And this, just relatively speaking, represents high accuracy and high precision. So I hope that helps you understand those two terms. All right, now moving on to other terms is reliability. Now, this is when you don't control your variables, and so it's usually something else that's causing the change, and not because you think there's one of the uncontrolled what's meant to be controlled but's uncontrolled, and you're measuring that instead, which is hilariously funny in things like psychology and other sort of areas that claim to be scientific and throw the word science in front of them. And for us, temperature changes during the day. It's still not completely unreliable, but it is going to give you different values. And so it is an issue of reliability to some degree. And then validity means you're not even testing for what you're saying you're testing for. So in psychology, the best way they do this is to try and trick people into thinking they're getting tested for something and they're getting tested for something else, so they can't purposely screw it up, because that's the nature of biology. And this one here is probably one of the ones that I can think of, and I can't even think of anything else. They were cutting these up, saying that the surface area increases, which is completely insignificant because it's that little line in between the cut that increases the surface area. And then what was happening is those little pieces were sticking together. And so there was a massive decrease in surface area. And so that was definitely an invalid experiment, but pretty rare. It's pretty hard for that to do those sort of experiments, but that was humorous because it did actually happen. And so, as I'll say in the data table, never use discrete data, discontinuous data, because the whole reason it's discrete is because there's just so many uncontrolled variables here. So if you're not doing a scatter graph where everything's controlled and you're only changing one and only measuring another, you might be doing biology and not physics and chemistry. So this one here, you might be testing the effect of, energy is due to glucose. You're testing the effect of your energy on what drink you drank. The energy before and energy after, but there's the novelty effect, like placebo. There's the different ingredients in these things. It could be some other factor. One of them could have caffeine, or this one's got glucose in it, so it could be due to anything. Lactose intolerance, I don't know. So could be due to what time you woke up in the day. So it's just, as soon as you start comparing literally apples and oranges, you can't really. Okay, so that's why validity and reliability are the big issues in bio, and that's why they just have to take huge numbers and do statistics. Whereas in chemistry and physics, you can even get away with a repetition of 2 if it's like a titration. But as I said before, as I will say, we're going to start to use some statistics. So we're sort of asking for a repetition of 5. So make sure you have a good understanding of those 4 definitions and use them correctly when you're writing your IA.